Hi, I'm Rachel Myre, and I'm going to be talking about the gummy bear experiment in water, and it explains how osmosis works. The materials I used for this experiment are 3 purple gummy bears, 2 clear plastic cups labeled salt, and 1 labeled water, 300 milliliters of tap water, 150 milliliters in each cup, 3 tablespoons of salt, 1 kitchen scale, 1 clock, 1 ruler, and 1 paper towel. The instructions, so I measured each bear's length, width, and thickness, then log on raw data sheet. With the kitchen scale, I weighed each bear, then log on the raw data sheet. I poured 150 milliliters of tap water in each cup. I poured 3 tablespoons of salt into the cup labeled salt. Stir salt until it dissolves in water. I placed 1 bear in each cup, and I left 1 bear out of the cups as a control bear. I logged the time the bears were placed in the water cups. I let the bears soak for 9 hours, and after the 9 hours, I repeated steps 1 and 2. The definition of osmosis is the movement of water molecules from an area of higher concentration to an area of lower concentration through a semi-permeable or permeable membrane. And you can see that in the picture that I included in the slide. I also added the definitions of hypotonic, hypertonic, and isotonic solutions. Hypotonic solution causes a cell to swell. Hypertonic solution causes a cell to shrink, and isotonic solutions do not change the volume of a cell. And you can kind of see how that works with the picture that I included at the bottom of the screen. You can see that the hypertonic solution had the water move out of the cell. The hypotonic solution had the water move into the cell, which caused it to swell, and then the isotonic, the water moved back and forth, and it didn't really have a higher concentration on either one. So my prediction for this experiment, a gummy bear placed in tap water will swell and the mass will increase. A gummy bear placed in saturated salt water solution will shrink the mass and will decrease. And this solution of salt water will be supersaturated because it will not dissolve all of the salt because it has so much salt in it. My hypothesis, the gummy bear placed in the tap water solution will increase in size and the mass as a result of osmosis because water is a hypotonic solution. The gummy bear placed in salt water will shrink in size and mass as a result of osmosis because salt water is a hypertonic solution. You can see my data on these tables here. You can see that before you have the purple bear, you have the length, the width, the thickness, and the mass. And then after 9 hours, the length in tap water increased, and the bear. The width also increased, and the thickness increased, as well as the mass did. For the salt water, you can see that the bear before the length, the width, and the thickness, the length decreased, the width and thickness didn't change, and the mass decreased. And then the gummy bear in no water, all of the measurements, length, width, and thickness, and mass stayed the same. Here I put the percent change in mass. The gummy bear in water, you had the initial mass in grams, and then the final mass, the initial mass was 4 grams, the final mass was 7.08 grams. You can see that the percent change was 77%, Gummy bear and salt, the initial mass was 4. The mass changed to 3.11. There was percent change was negative 22.25%, and then the control gummy bear did not change, so there was a 0% change on that. Here is a graph showing my results. This is a picture of my results. You can see the control gummy bear at the first part of the paper. On the second part, with the tap water labeled underneath it, you can see that the gummy bear kind of exploded and expanded. And then the tap water with salt, it shrank a little bit, got a little hard, and that's because it's a hypertonic solution. So my results for the gummy bear and tap water. The mass of the gummy bear increased 77% from 4 grams to 7.08 grams. The length increased from 19.05 millimeters to approximately 25.4 millimeters. The width increased from 12.7 millimeters to approximately 19.05 millimeters. Thickness increased as well from 7.93 millimeters to approximately 12.7 millimeters. The color of the purple gummy bear changed from a deep purple to a pale purple. After 9 hours, the bear became very fragile and soft. After weighing the bear fell apart when I picked it up to move it. So I used a metal knife to put it back together as best as I could. For the results of the saltwater gummy bear, the mass decreased by 22.25%. It moved from 4 grams down to 3.11 grams. The length decreased from 19.05 millimeters to 15.87 millimeters, and there was no change in the width and thickness, which remained 12.7 millimeters and 7.93 millimeters, respectively. And the color of the bear changed from a deep purple to a blue-gray. And the bear's texture became harder and was not fragile. So osmosis is the movement of water from an area of higher concentration to an area of lower concentration. The gummy bear has a semi-permeable membrane, so in this experiment, we could witness the effects of osmosis when the bears were placed in both a hypotonic tap water solution and hypertonic saltwater solution. The gummy bear swelled significantly in the water solution, hypotonic solution. This is an example of osmosis in the hypotonic solution, where the water flowed into the semi-permeable membrane of the gummy bears and caused it to swell and increase in mass. The gummy bear in the saltwater solution shrunk and length lost 22.25% of its mass. That's an example of osmosis in a hypertonic solution, and it caused the bear to shrink. The swelling and shrinking of the bears in the hypotonic solution, hypertonic solution is a great example of osmosis and how water can flow through a semi-permeable membrane. In conclusion, the tap water is a hypotonic solution with respect to the bear. Therefore, the bear increased in size and the mass as predicted. The water concentration in the bear was lower than what was in the tap water, therefore the water left the solution and entered the bear in order to create equilibrium. The saltwater solution is a hypertonic solution with respect to the gummy bear. The water was saturated with salt, so the water concentration in the solution was lower than what was inside the bear, therefore the water left the bear and entered the solution in order to create equilibrium. Sources for error. The bear in the tap water solution became very fragile and fell apart when I picked up with my fingers to move it. This human error may have given inaccurate measurements of length, width, and thickness, and mass. And that is the conclusion of my And
That
that
concludes.
concludes my presentation. Thank you.